All right, guys, let's do this. Let me catch up to you.
Let's see what we got.
So when you made this stem and leaf plot, what were your stems? My stems.
1 through 5.
That's crazy. And then your leaves, for 1, there was only
2
2,
through
3, 6. For 2,
none.
so yeah, none. Good. So definitely still put the 2 there, because then that's an empty class in a sense. If you don't put it there, you're sort of trying to be misleading again. 3 is going to have a few, right?
Yeah. 1, 2, 2, 3, 5, 7, 8.
Tubular. I like that. Thank you. And then 4,
1, 1, 5, 6.
and then 5,
0,
0,
2.
2. I like it. And is that complete?
You need a key.
Need a key. Notice there's no commas. Right? It's a little thing. And then the key here, I could say 1, 2 equals 12 or means 12 or something. Just need one thing. So like you just need one scale on a map, and then I can read everything between towns. I like it. Cool. And then this one, I understand it was a little bit weird, but I just didn't want to leave stem and leaf without showing you some of the more powerful things it could do. If I just made a 4-row and a 5-row, that doesn't really show me anything. So I want to break it down further into 4, 4, 5, 5. So what you got after the 4, you got O,
Oh.
O,
2.
2. What about after this now? This 4 starts at
5.
5.
5, 6, 8, 8, 9.
8, 8, 9?
Yeah. There's 2 5s.
2 5s. I thought I heard that. And then this 5 starts at 5, 0.
0. 1, 1, 2, 3, 3, 4, 4, 4.
And then this 5 starts at 5, 5. Those are
5, 7, 8.
5, 7, 8.
Mm-hmm.
So now you can see a lot better what I call resolution. I can see exactly where it seems like most of the data is clustering. They seem to be clustering around the lower half of 5s, 5, 0 to 5, 4. All right, and what's my key going to be?
4 / 0.
Sure, 4 or 5 means 4.5. I like it. Kick ass. So if you don't put the key, you're going to lose a point or 2. So just put the key. I like it. And then I like to give this number 3 problem because it's a completed histogram. You really just have to see what they did to answer these questions. But it is a little bit of turning your brain backwards based on what we were doing. So here, I didn't mean for this to be tricky, to be honest. It kind of cut off here, but this is 11, right? It's like halfway. So how many total consumers were there? 11, 6, 2, 1. So there were a total of 20. How many classes are there? There are 2 empty classes, so there's a total of 6 classes. And what is the class with? 20. So I didn't have to do work there because I can see how wide the classes are. But if I did do the work, and again, I don't know if 120 is the highest, right? 110 could have been the highest. I don't know what's in here. But 120 minus 0 is 120 divided by 6 classes. What's 120 divided by 6? 20, holy shit. All right. So you didn't have to do that, right? Get over there, Halls. You didn't have to do that. I'm just showing you that's kind of like what they did to get that width. And now, this question, you have to know what at least means, right? And it's not your fault. I think they're just, I don't know, man. Do you know what the word of means in math? 20% of 75. What does of mean? What operation? How would you do 20% of 75? I hear times. It's times is right. So everybody used to know, coming out of high school, of means multiply. Now maybe 10% of people know that. And I'm like, what is happening? But of, so if I had 7 crates and each crate had 8 apples, I have 7 of these crates, 7 times 8, I got 56 freaking apples. So of fundamentally means multiply. Sorry. That didn't have anything to do with this. This is another example. But at least is something else that people don't get. But if you have to be at least this tall to ride the ride, I don't know what ride this is. That tall to ride the ride can my son, I don't have a son by the way, can my imaginary son ride that ride?
Above.
No, so what does at least mean? This or
Above.
more. So what's at least 40?
40 and above.
And how many people are there?
3.
3 total out of?
20.
There you go. That's how you make a percentage. Part divided by whole. And we did that one on the practice thing, but you guys, what do you get?
15.
That's right. 15%. I'm probably right here. I don't know. Shampoo lasts me for
2 years?
Sure. Maybe it's not me. I don't know, man. I don't have much hair. This one, we sorted these. That's part A. That's all I had to do. Part B, I can't do anything with that sorting business until I know how wide, until I set up my classes. So what was the range on this one? 18. And I told you to use 5 classes. So that's 3.6 round up to 4. If you don't show me this work, I was almost going to wear my show your work, but I figured I'd wear that on Monday or Tuesday. But you got, if you just do 18 over 5 and then you go over here and you make 4 width and you're like, wait a minute, where'd that come from? So you got to kind of finish that out for me. So where am I going to start? Hopefully everybody started at 61, which means this would go at 65, right? 4 later, and then 4 later, and then 4 later, and then 4 later. And then this has to be 1 down from there, and then 4 later, 4 later. All right, Jeff, we get it. Now, if you did it with the inequality method, awesome. You can check with me if it was right. That's the way you should look if you do the book method. Now, if I do this method in my table, I must do the up and down by a half on my histogram. You can't just suddenly change methods in the middle of everything. No. What do you guys get for your frequencies? 2, 11, 13,
7.
7,
And 2.
2. Yeah, this is right. How we doing out there? Okay. And so this does add up to be, thank God, 35. Check. So what's the relative frequency, Kenneth? 215, 2/35. There it is, Jeff. 2 divided by 35. Yeah, 5.7. And then 11 divided by 35.
31.4.
31.4. I appreciated the emphasis. And then 13 out of 35.
37.1.
And then 7/35 is nice. Because that's just 20%, right? Good old 1/5. And then 2 out of 35 is nice because we already know that weirdness. All right, now, I put the cumulative frequency up here because it's in chapter 1. It does exist in the wild, but it's barely ever used. So I'm not going to ever ask you a cumulative frequency question. So you can basically just not pay attention, but it is exactly what it says. It accumulates the frequency as you move. So as I move down, how much frequency have I collected? How much relative frequency have I collected so far? 5.7. Move down again. How much total do I have now? Add these. That's right, kids, 37.1. Right, as I move down, I just keep accumulating the frequency. So what's that plus itself? And then you add the 20. And then you add the 5.7, which matches up with what that adds up to be, of course. That's cumulative frequency. Is that cool? So you have to do that in the homework, but I'm not going to really ask you that question on the test or something.
I feel like it'd only be useful if they asked like an at least this much question. And you can do like 100 minus.
Yeah, that's how useful. There are other types of graphs that I don't teach because they're not used as much. There's a graph based on the cumulative frequency, but then it's sort of like you have to see the jump to see how much is actually in that class, so it's not used that much. Yeah. All right. Is everybody cool with that so far? Okay. And then, since I did this way, I must make this scale not 61. I got to start where? Step off, right? Don't come up on me at 61. You got to start at 60.5, a little bit below 61. And now, once you write that, you're golden. What was my width again? 4, so just go up by 4. Now, if you did it the inequality way, this would be 61, 65, 69, blah, 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 right? Nice whole numbers. This, but I want a relative frequency histogram, right? So you can put RF there, that's fine. The real freak. And how far up should my highest bar be? It only has to go up to what? 37. So maybe I go up to 40. Don't make this 100. If you make this 100, your whole histogram is smushed down here. You're going to use all the space, right? So if I want to go up to 40, maybe I go by 5s. 5, 10, 15, 20, 25, 38, 35, 40. Cool. I can count, but I can't write. So then this bar is going to be how tall? 5.7 roughly, and then 31.4, and then 37.1, and then 20. Looks like this is going to fall over. Sorry. And then 5.7. What have I left off? Anything missing? Yes? No? Yeah, label at the bottom. And what were these measuring here? This was... I guess it only need apostrophe. I don't know. Father's heights is sort of implied to be in inches, hopefully, not in centimeters. Hey, Dad, how you doing? Yes?
Is it mandatory to offset the upper and lowermost
Yes, if
ranges?
you do the table using this method with the boundaries, then you have to use the limits.
But specifically on the very top and very bottom, because there isn't anything outside. Like if you set it the lowermost at 61 instead of 60.5, there's no gap on that side. You see
Oh, I see. But you want the width of your bars to be
Okay.
the same. So you have to apply that everywhere so that they end up being the same. Otherwise, it seems like you're trying to trick things somehow, which is something you want to look out for in these kind of graphs. Okay. All right, so moving on. Let's see. We're going to get into, let me make sure I've got this in the right order. I think we want to do percentiles next. No. Yes. Sweet. Has everybody taken the SAT test?
No.
You guys? They used to report the results in terms of percentiles. Do they still do that? Do you know? Yes? No? Some of you guys are saying no, yes. Aw. I'm telling you what, kids, get Gorilla Glass. All right. Oh man, Jeff, give me a minute.